In this video, we're going to go through an example where we find the interpolating polynomial. Specifically, we're going to find the second interpolating polynomial for this function. These are the points that we are going to use. And so we might observe, so our points are 2, comma, then what is our function value at 2? Well, that function value at 2 is 1/2. And then we have our second point is 2.5. So 2.5. And then the function value at 2.5, at 5/2, is 2/5. And when our function value is 4, when our x value is 4, our function value is 1/4, right? So here we're just plugging our points in there. Now we're going to build our Lagrange interpolating polynomial. And we'll build it piece by piece. So L0. So the number of points that is known, we know that it's 3. And so I'm not going to write L30, although you could write it as L30. What are we going to do? Well, we're going to skip over this first point. We're going to take x minus the second point, so x minus 2.5, and then x minus the third point, the third x value, x minus 4. And then on bottom, we'll take that first x value that we skipped over, and we subtract 2.5, and we subtract 4, right? So you can think about, on the bottom, you are just plugging this value into whatever you would have got into your x places on top. And so that is L0. L1, instead of skipping the first point, this time we skip the second point, or the point that's associated with x1 for L1 is the one we're going to skip. And so here, we have L1 of x is equal to x minus 2 times x minus 4. Then on bottom, we will have 2.5 minus 2, 2.5 minus 4. And then for L2 of x, we're going to skip over our third point. So we have x minus 2, x minus 2.5. On bottom, we take that third point, that third x value, we plug it in, and we have this. Now, this is not the polynomial. These are really the building blocks of the polynomial we're trying to get to. And so what is the polynomial that we want? Well, the polynomial that we want, p of x, it is L0 of x times the function value at x0. So it's going to be 1/2 times L0 of x. This does have an unknown x value in it. It has a variable x value because this is a polynomial that we are constructing. Then we're going to add to that 2/5 times L1 of x. And then we will add to that 1/4 times L2 of x. Remember, this is coming from the function value at x2. And this is the function value at x1. And this is the function value at x0. Right? So those are the values that we identified up above just by plugging those points in. Right? So those are known values for this polynomial that we had. Next time, we're going to look at a quick argument about why this procedure, constructing our Lagrange polynomial in such a way, why it will guarantee that we're going to agree at each of the points. All right, we will see you there.